Welcome everyone to today's webinar where we're going to be talking, where we have Adam Goucher talking about, is your automation infrastructure well architected? So Adam Goucher is the CTO of MobileXco. I'll let him explain a little bit more about that, but he's a former maintainer of the Selenium IDE. Personally, not sure why anyone would ever work with the Selenium IDE, let alone maintain it, but that's a cross he has to bear. I personally know Adam from his work with the AST. He's done a bunch of presentations at CAST. So if you go through the AST YouTube channel, you'll actually find videos, interviews with him, that sort of thing. I also know him from his Element 34 consulting. So he did a lot of consulting around Selenium back in the day, and he blogged a lot. So I remember coming across a lot of his blog posts. But that's Adam. And so Adam, why don't you go ahead and take it over?
Okay, so thank you. So there's like a ton of content here. So we're just gonna, that introduction's probably the relevant parts of who I am. So we'll just leave it at that. Basically, I'm an opinionated automation guy that's been around Selenium for a long, long time. But here's the thing around browser automation and such that is relevant to this talk and is super relevant to the world at large right now, which is basically, I am of the opinion, or maybe the conceit, that browser-based automation, and probably can be extended to APIs and such as well, basically we solved that 5 years ago, and the solutions that are coming out now are just basically small iterations on that, or wrapping them up in a nice marketing envelope. The thing that isn't addressed yet, and is the hugest business risk, I believe, is the infrastructure and the procedures that we have in place around our automation environments. In my experience, both as an automator and as a consultant, our automation environments tend to be run by the teams that are automating, and are not subject to the same controls and rigor as the production environments are. But usually these are exposed to the internet, which means that if it hasn't already happened now, it will happen, I guarantee this, in the next couple of years, where there will be a large data leak that happens because the automation environment was the attack vector. I 100% guarantee that statement. So we're going to talk about how a whole bunch of concepts around how you should a framework for thinking about your environments to mitigate that risk, because I personally do not want to be responsible for maintaining an environment that gets slammed with a huge GDPR fine. If I'm actually in the window, it works better. All right, so when I'm talking about your automation infrastructure, there's three big buckets, all of which can be used interchangeably for the rest of the slides. There's the actual automation framework, which I'm calling your scripts, the actual test runner, the drivers that are driving the browsers. PHP unit, your PHP scripts, and your Selenium browser drivers. There's the actual application under test, which you need to also think about how that's being ran, maintained and executed against. So that's your app. And things like third-party services that you are integrating with and have connections from your infrastructure to. So possibly a payment gateway, their test environment, or even something like Sauce Labs. You've had to punch a hole in your firewall in order to access it. So when I throw the nebulous term automation infrastructure, it means all these three things, not just your application, not just your scripts, not just third-party stuff. Okay. This slide I thought I took out, but that's okay. So basically the goal is, we want our automation environments to be production representable, but then not actually be like production. So if production has 18 nodes in its cluster, we don't need to have 18 nodes, but it should really only have one or 2 nodes, so we have cluster stuff. And why not strive to be better operationally than production? In theory, we have less stressors and constraints. In theory, yeah, reality, not too sure that's always true. Okay, so but for what we're really talking about today is totally not my idea. It's just something that I have stolen and made it, put my twist on, which is the Well Architected Framework, which is designed by Amazon for their AWS services, and how to really think about how you architect your cloud environment in specifically using their tools. But if you sort of look at it from a little bit of a distance, it really is a cloud neutral framework. It's just how they implement things obviously use all the Amazon tooling. But if you ignore the actual here's how you implement this idea inside Amazon, it's an excellent framework. And it's really starting to get a lot of promotion on their website and their training sites. Which, unfortunately, that promotion started literally the week after I gave a talk at the Selenium Conf in Austin, I guess 2 years ago now. And it was disorganized and had nothing to hang on it. And then this came out and I'm like, oh, wow, that would have been convenient. So I have literally like 30 slides on this stuff, which means maths out to like minute and 10 seconds per slide. Which is just not doable. So what we're going to do is focus on some of these things and blitz through others. All the slides will be available, so you can, if something twigs and you need to think about it further, you can look at the slide and the content that goes along with it. And there'll be some extra stuff that Chris can send around to the attendees after as well. Okay, so the actual well-architected framework is based around 5 pillars. They're listed here. Inside each of these pillars is a number of principles. Some of them have 6 principles, some of them have 4 principles, that sort of thing. We're gonna focus on one principle on each pillar and just skim over the rest, just in terms of expedience. So the first pillar is operational excellence. And so this one is first in their documentation. And what I have found in my experience is this pillar, the principles in it are also the biggest pain in the butt to have to reverse engineer into an existing environment, which most of us will have to do. It's very rare that at this point, that you go to an organization and there is no automation environment in place. So when I started automating back in '98, I would change jobs and have to build an environment from scratch. And I could just start doing this stuff now, or right from the get-go. But now it's backporting and it's not very fun. But that's what we have to do. So the very first principle, and this is the most important one, I think, in this pillar, which is perform all operations as code. So this is something that the continuous delivery people have been harping at you for a decade about, but is super important. So anytime you provision, so that is lighting up a new EC2 instance or a GCP compute node or a container, or configure that piece of cloud infrastructure by hand, you are doing something wrong. Somebody should come around with a ruler and crack you over the knuckles. Do all this stuff write them as scripts, treat it as code, check it into version control. If you're using like a Git workflow, do pull requests against master. Do code reviews on this stuff, because this stuff needs to be reproducible all the time. And the only thing that way you can do this is by having code that gets executed. There's no opinions. There's no, oh, I forgot to read step 3, or I didn't think step 13 was important. That's, I thought you just wasted your time writing step 13, so I skipped it. And then we wonder why it doesn't work, or why it only sometimes works. I did, a bunch of consulting. I got called out. Oh, I got flown down for a lunch and learn to Chicago one time, and they were picking my brain around automation environments and stuff. And it's just like, guys, you guys aren't ready to do automation yet because you don't have your environments under control. They were building all of their nodes by hand. Production had 64 web application servers in production, and one had a different number of database threads or something, and so it kept on. There's a random crash. So they weren't even ready for automation yet. But for us, same thing. If you can't bring up your environments by running code, then I would argue you should not be even creating scripts yet. Similarly, anytime you log into a box to do something you've found, that should be a trigger that you need to convert something into code. And this could be, at a macro sense, I need to look at a log. Okay, well, shouldn't that log be pumped out to a third-party log server aggregator somewhere? Or maybe it results in a change to your application to have logging inside your application so you can see it. Ideally, your instances should not even be able to be SSH'd into. So all your configuration, if you get nothing else out of this webinar, all your configuration of your automation environment, from the moment you want to spin up a piece of infrastructure, be it the instance that the app runs on, the instance your Selenium Grid server runs on, your sauce tunnel instance, your containers that do X, Y, and Z, or the database or the caching server, that needs to be able to run from one command, pulling out a version control somewhere. And if that's all you get from this webinar, we have succeeded. That said, I'm going to throw a whole bunch more stuff at you. Just as a quick note for automation purposes, like for our writing browser automation, for the orchestration or provisioning of your applications, I would probably lean towards a tool like Terraform because it is multi-cloud. And AWS has CloudFormation, which is their own tool for provisioning. But what if you want to run on a Mac, and so now you're into various other Mac cloud providers that use VMware, and CloudFormation doesn't work with VMware or non-AWS stuff. So I would probably look at Terraform for that. Configuration of your servers. I personally really enjoy using Puppet, but I know other people that use Chef. There is some pain in the butts with, environment certificates changing, but there are all these things. There are solutions to out on the internet. And then not interacting with the box, not logging in. An AWS specific tool is something like AWS System Manager, which has an agent that runs on the box, and you just tell it to run commands. So yes, control everything via code. Now we're going to start flying through things. All your code should have comments, and they should have accurate comments. And most tooling has the ability to say, or has a project out there that will take the comments and convert documentation in real time. So when you check in your code to update your environment, then a part of the build pipeline kicks off to regenerate the documentation, and it's just constantly updated. Add that into your Jenkins instance as just a build pipeline when you check in your code to build your infrastructure. Tools like Sphinx for Python are in this nature, but I did a quick search and found stuff for Terraform, CloudFormation, for Puppet. I think there's all these tools exist already. You just need to wire them up for your environment. Make frequent, small, reversible changes. This should be preaching to the choir for testers. Oh, we made 15 changes and something broke. What could it be? I don't know. We made 15 changes. So anytime you are making changes to your scripts that control your automation environment and your commit message, because again, you're checking them into version control, if your commit message says, and you have done too much. So think about what you've done. Maybe you need to break up your commit into two or more pieces. Check that in, apply it to the infrastructure, make sure it works, check in the next one. And is not your friend in this particular case. This is another one, quick one. It just says, refine your operation and procedures frequently. Again, do code reviews. Schedule something on the third Tuesday of every month for an afternoon to look through all of your libraries that you're using for your infrastructure tooling to see if they need to be updated. Has there been a new pattern discovered for configuring things? Or did you suddenly hop on the observability bandwagon? And so now you need to look at how to update your tools. Did the ops team get a new tool that you can use, et cetera, et cetera. Just the idea is, put it into your calendar, because if it's not in your calendar, you will always forget it, or somebody else will just not respect your time and just book you solid. So put it in your calendar. Don't let people schedule over top of it, and just go through your list of tools. Update things as necessary. This is a whole topic onto its own. Anticipate failure. Let's just accept that failure happens. Accept it. Actually, you should probably embrace it. There is nothing more annoying or terrifying when you don't have your environment fully scripted to get the notice from Amazon that says, by the way, we are taking down your main production, your main environment instance tomorrow at noon. Have a nice day. So, that's if they give you warning. Sometimes things fall down. You need to be able to bring up your environment quickly. I would argue that you should probably build these, chaos into your automation scripts after you do all the ones that the business really depends on. What happens if, as part of your script, you shut down the Redis caching layer? Does the script fall? Does the application fall over because it can't find sessions, or does it gracefully display a page saying, "Oh, sorry, we're having maintenance"? So you can build that right into your automation scripts, but I wouldn't run those ones all the time. Maybe every 200th run, maybe at midnight on the 1st of every month, you run these scripts. You can break your scripts up by functionality. I want to say it's Netflix has the Chaos Monkey. They released a framework that will just randomly screw things up for you and have your application behave. They run it on their internal networks, maybe LinkedIn, I'm not sure. But large companies are now managing for chaos. You can look online, I guess a year and a half ago or so, Facebook basically just went up to the main power switch inside their London data center and just pushed the off button. And they had spent the time to just, their network magically healed. But they had spent the time, they had tested it out in their lower environments, in their automation environments, what would happen. So why not build that into your test suite and into your environment? Again, standard little disclaimer there. Things are only a mistake if you don't learn from them. So what if something fell down? Did you learn from it? Did you write code or infrastructure code or some sort of healing code to fix it? Yeah, awesome. So guess what? It wasn't really a mistake. So second pillar, again, talking really fast, I know. Those of you who see my talks in the past, I harp on this one a lot. For security, you gotta have a really strong foundation. If you don't have a foundation, you don't have anything to build on. So in a cloud environment, anytime a human is actually interacting with your environment, like at your infrastructure level, require multi-factor authentication. Passwords are just not enough anymore. SMS, two-factor auth can be intercepted and broken. There's lots of papers about how that happens. Software tokens is probably what you want to use. These things are built into all the cloud providers. For your root account, you need your main account that has all the access. You want a hardware token. They're $40 or something, and you just lock it up somewhere safe. Our company's token is sitting in a safety deposit box. So if I need to get access to it, it's got to be during business hours. But if I need it, there's far bigger problems than worrying about whether or not a bank is open. Because I use everything. You don't do things as root, as the Unix people have taught for years. If you're using tokens, here's a fun game for you to look up later. You can find all sorts of people's AWS tokens sitting in GitHub because they've checked in their config files. So that it's kind of easy to figure out what the string looks like. So use short-lived tokens for all interactions that need tokens. Ideally you would not be using tokens, but if you do have to, make sure they're short-lived and practice rotating out your tokens. Because if somebody pushes your read-only token for your build server onto a public GitHub repo, you probably want to change that. But you would be amazed how deep and the corners that these tokens can hide in. And all of a sudden, if you invalidate your token, your entire build system has fallen down, your build pipeline has fallen down, and you can't push to production, which is not ideal. And for internal communication between services inside your cloud vendor, use their version of service roles that they authenticate between each other. You can even do things like, if it comes from this IP address, then allow it. But this is super, super important. Again, another thing, if you take home, log into your AWS or GCP or Azure accounts and enable two-factor auth on all of your human interactions with the console. There are scripts available that will crawl the APIs and tell you who hasn't got it enabled, or when was the last time your tokens were rotated around. Again, I can provide links to Chris and send them out along with the deck later. Turn on all your logging in your automation infrastructure. You'd be amazed what sort of things that can provide you. And it's the very first thing, if you are compromised, that the security team or whatever will want to see is the logging. I'm not sure about providers other than Amazon, but I know I've got some clever things set up where CloudTrail, which is their API logging tool, is enabled on all regions. So if I have CloudTrail set up in such a way that if somebody disables it, it will pump that message through CloudWatch to SNS to Lambda, which will then immediately re-enable CloudTrail in that region. So, in my infrastructure, you cannot turn off CloudTrail without jumping through a whole bunch of other hoops, which have other monitors. And, at some point the rabbit hole gets too deep, but it's enough that I can find, with the monitoring in place, I can find out if people are doing shenanigans in my environment. Here's a standard one: apply security at all layers. There is no such thing as a trusted network. Oh, it's behind your firewall, it's trusted. Yeah, it's trusted until somebody takes their computer home and their 8-year-old is trying to find Minecraft skins and unleashes a huge virus all over your browser and your system, and then you jack into the corporate network, and now everything is screwed up, and just because you didn't have password enabled on your laptop or you didn't have it shut off. And certainly the 8-year-old looking for Minecraft skins is only a hypothetical question, a hypothetical story, and never happened to the person talking. Here's the best practices word. We can live with the best practices word in this case. But here's the thing about best practices, or really good practices that you probably should really do, except for the ones that you should ignore, at which point ignore them. They're constantly changing. In the automation world, again, we used to say, implicit waits were a great thing because your scripts will be less flaky, until your implicit wait code waits for an hour for your page to refresh because you didn't tell it to stop waiting, and your scripts execute far longer than they need to be. So then the best practice became explicit waits are what you should be doing. So these things change. You need to be aware of what these things are, how these are changing. And your cloud provider's blog, public blog, will list all of these practices and how they are constantly changing. But again, and all your security controls, because they really are, from a cloud perspective, infrastructure, are embedded into the scripts we talked about on the very first slide. So if you are creating a security group, you aren't doing it through the console. You are creating a security group in CloudFormation or in Terraform or whatever, and then you're applying it. You are not doing it through the browser. This should be common sense at this point. Encrypt everything always. When it's being sent over the wire, when it's being stored, especially if you have anything that is close to being personally identifiable information, because even anonymized data becomes personally identifiable at aggregate, which is why anonymization doesn't really work as a security control. And then apparently a cat showed up. Anytime you're transmitting data or storing data, encrypt it. It's usually just a flag. A very noisy cat is here. Also, please don't copy your production database down into your automation environment. Please, please, please don't do this. There's no real good spot on this framework to say that, so I'm going to say that here. Data is a liability. You do not want the liability of having production database in an environment that you control. Create your own data. This is an important one, and a lot of it, this one, when I talk to people at conferences, they don't really have a plan for. So if we go under the basis that there is no such thing as a trusted network, then the corollary to that is that you will have a security event. You're crazy if you think otherwise. So do you have a plan of attack, or a plan for when you are attacked and attacked successfully? How are you going to react? Do you personally, when you discover something, know who you need to talk to in the chain of command? What's their phone number? What's their email? Is there a page that you need to go to? Do you know who you're going to talk to? Is there a plan? There needs to be a plan for every environment that you run. There should be one for production, should be one for staging, there should be one for your manual test environment, there should be one for your automation environment. They could be variations on it, but maybe it's for production, it's the CTO that gets called. For automation, it's the VP of engineering or something, because it's not as high level, unless you're copying production data in, which you shouldn't be doing. Here's again, to use the best practice, phrase again, the very first person that should be contacted outside of your organization is your insurance company. It is not the legal team, it is the insurance company. You bring in the legal team only after the insurance company says that it's okay to call the legal team. That's not legal advice, but that is general, a best practice that I have seen, because now the insurance company, there have been a number of cases that I've seen on Twitter and various other places where the insurance company has tried to deny a claim for a hack because you didn't call them in time, or you did not share information with them as quickly as was required in the policy. So call the insurance company first, and call the lawyers when they say to call the lawyers, which will probably be very quickly. But is there a plan written down somewhere that says, if there is a security event in this environment, who gets called? What is their cell phone number? What is their home number, if people still have home numbers? If you don't get a hold of them within 10 minutes, who's the next person you call? Who's the next person you call? Like, that should be written down somewhere and pinned in, a shared Google Drive or a Slack channel or something. All right, reliability pillar is a fast one. So as we talked about with chaos, failure is not an option, it's a feature. Have you practiced a restore of your database backup? Most people don't. There's all sorts of horror stories of, we went to restore the backup and it was corrupted, and so we were screwed. Test environment, it's not as deadly if that doesn't happen. But what is becoming more important is frequently our automation environments are a key node in our release pipeline. So you cannot even unlock the next step of deployment until you are green in an automation environment. So if your automation environment falls on its face and you haven't practiced restoring it, or the person who knows how to restore it is on vacation in Mexico for a week and you can't contact them, that implies that you can't push to production until they're back. So have the recovery procedures. Everybody should know how to restore the environment that is, that is using that environment. It should just be, welcome to the team. Here's our automation environment. Here's how you access the various parts of it. Here's how you restore it. Here's the scripts, because again, configuration and restoration is just executing scripts. Here's how you do it. You can even do cool things like automatic detection and recovery of failures. So your application and your production team may have already started working on adding these features in. You just need to pull them down into the automation environment. Is, how do we tell when a server is acting cranky? How do we tell when a component of our application that runs our application under test has fallen down? How do we bring it back up? So some of this stuff could be Puppet scripts that run every 5 minutes to check that a process is running, and if not, then you restart it. A queue got stuck or fell over, so restart the queues. How do you check the queue health? Is the queue getting backed up? Is there more than 25 things in the queue in a 5-minute period? That's not normal, because we'll know what normal looks like in our automation environment. So then maybe spin up another instance, or kick a diagnostic script off, or manually trigger a notification in PagerDuty. But there's all sorts of fun things you can do. And I realize there's some level of sickness there, trying to diagnose when something's about to fall over and prevent it through scripts as fun, but it kind of is fun. All the environments allow you to do that sort of thing with their SDK, which is probably already embedded in your application code. This is again more just basic cloud economics, scale, have multiple smaller things instead of a single larger one, not only because it's cheaper usually, and there's a whole economic section later, but at some point, your company is going to grow, hopefully is going to grow, beyond a single server or for any particular process or application. And it's going to be over a cluster. What your environment should probably represent that by being run in a cluster. So why not just start that already? Even if your application is just a single server monolith, run 2 small servers and see what happens. Again, we're running test automation environments. Find the bugs. Find the bugs before you need to find them. And of course, stop guessing at capacity. You can measure all the things. I know, so when I started automating back again, 98, but really full bore in 2000, 2001, we literally had a rack of machines per person because we didn't know how much we needed. We just ordered a lot because we had a really big budget because it was the cloud bubble, or it was the first internet bubble. But now we can measure all the things and then respond automatically in terms of capacity. Hopefully your production and team is already doing this sort of stuff, and you can just borrow all their metrics, because what you're actually measuring is what the business cares about. I really, truly do not care what the CPU load is on any of my machines or what the memory load is. I care about what how many of X can I do in Y time. And it's in a constant rolling average. And when that rolling average goes over a specific number, then I respond accordingly automatically. Maybe I need to add another instance into the cloud or into the cluster, and that will pull the number back down. This is the magic of the cloud. This is the elastic part of elasticity. So, run your scripts reasonably or with realistic load settings, have the measurements of the business value and scale accordingly. And so realistic load scenarios in this case are have many, many people accessing your website, your application at the same time. One of my pet peeves, I have a lot of them, is people that run their automation scripts in just a single line, one after another after another after another. If that is a realistic representation of your production environment, you're not going to be surviving too long. You need to have lots of people running against production environment in order to stay in business. Replicate that scenario in your automation environment. So with that realistic load, measure the variables that the business cares about. You can scale them down for the automation environment, but then have your automation environment adjust automatically. And again, this is a variation on what 2 or 3 already. But Amazon's designed this that you can do each pillar independently. You can do each design principle independently. But this is really useful to harp on. Your automation should not be a work of art. You should not be logging into server A and just making this tiny tweak just this once. And it should, that change, if you needed it on server A, you probably need it on servers B, C, and D as well. Do it through code, provision the code. Your maintaining your automation should be painfully boring. It's amount of, it's editing JSON files, it's editing DSL files, it's editing YAML files. Should not be a work of art. You should be able to destroy your works of art and not cry. Again, I've had it, automation machines 20 years ago that hadn't been rebuilt in 3 years because they were just configured just in such a way to work on with our app. But our customer machines were not configured that same way. And somebody was like, well, it worked. It worked in the test environment. Why did it not work for them? Oh, that's right. That's why. So manage all your changes, in your automation through code, checked in with the same level of rigor that all your production code has. Performance. Again, these ones are fast. What are we doing for time? We're just about right. Okay, so Amazon, this is where Amazon gets a little salesy. I don't work for Amazon. I just think it's a cool framework. So they want to democratize advanced technologies, which is just a fancy term if you read into it for, things don't need to be complicated. Allow the service providers to do the complexity for you. Back in the day, I used to understand the inner workings of 5 or 6 different LDAP machines because we needed it in order to configure our environments. Now, I would much rather have somebody, a cloud provider, do all the maintenance for it, all the updates, patches, configuration, give me a nice little web UI that I can click buttons on to set config files. All we need to know now is how do we test against it? We don't need, there should be a whole generation of automation people that do not know how to configure a SQL server, a database beyond, interacting at the client level, not how to run through the wizards, which options do we need and all that stuff. Let that, let a provider take care of that. So that's basically what that one's talking about. Go global in minutes. Again, more, hey, look, we've got regions, data centers all over the world, sales pitchy. But with our automation environment, there's nothing to say that we can't run our automation in Virginia and in Japan at the same time with a node of 2 things. Which if your production environment has distributed across the globe, why not run your test environment across the globe too? You could find all sorts of fun latency problems and other things that way. So why not run your environment globally distributed? After all, you are, within reason, representing production. So production's in 5 different Amazon regions. Maybe our automation environments in 2. These things do cost money. Again, Amazon really wants you to use serverless. They're kind of, pushing the whole company into that way. So use serverless architectures or don't. From an automation infrastructure perspective, the only really interesting thing that I can think of for serverless is if we're creating, what are vaguely called service doubles. So this is where you're like mocking out Stripe or PayPal or or Twitter or some other third-party service. We know what the web service call going out looks like, and we know what the response is supposed to come back as. So why not write a quick little serverless script that acts like Twitter? Now you're no longer hitting their environment. You don't have to worry about your tests falling down because they've changed their environments down for service, and you don't have to worry about round trip times and all that fun stuff. So that's, I think there's a lot of interesting things to be explored using serverless in an automation perspective, a browser automation specifically, where we're mocking out or creating service doubles for all sorts of third parties we interact with. Experiment more often, give us more money, but maybe you don't want to. Browser, in our automation environment, we tend to have a very specific charter for what we should be doing, which is testing the application. So is there room for experimentation in browser in your automation environments? It's very small. But why not have the production team play around in your environment while you're running your tests? They see how the application behaves while they're, replacing a link or something, which is, DevOps, the actual dev and ops teams working together. Crazy talk. So, all right, this one, is understand what success means. So this is, Amazon wants you to align your success metrics with what, the business can provide you. We need to understand as automator, what does success mean for the automation team? Is it breadth of coverage? Is it depth of coverage? Is it speed of coverage? We can go infinitely parallel in the cloud. And then, look at what services enable that. Because that will have ripples, especially on the date that you need to pay your bill, which is this whole other section, which there are entire businesses that are being built right now that are around managing your cloud spend. So figure out what your automation environments usage patterns look like and put things in place to automate the most efficient implementation of those patterns. And of course, that is done through code that's checked in. But what I'm saying here is, if your build pipeline is such that you are checking in this code, and then then automation runs, and then at the end of that, then humans gets deployed automatically to a humans environment where humans touch it, then it goes to staging, then it goes to production. And that your developers, the development team, don't work after 7 o'clock. Scale all your environments down to an auto scaling group, to use Amazon terms, of 0 at 10 o'clock, just in case somebody's working late, and scale them back up at 6 o'clock, because then you aren't paying any money for those environments, because you are, you pay either by the hour for certain components in the cloud, or that they just exist. So you can destroy entire environments and bring them up automatically. This is a big selling point for containerization, because those containers don't exist, and then you spin them up and they run, and you destroy them again, and your automation run costs 27 cents. And rather than just having a EC2 instance sitting around that's empty 70% of the time for $40 a month. There's a big difference in cost there, especially in a large organization. But also turn on billing alerts. I don't know what they're called in Google, but they are literally called billing alerts in Amazon, because if you know what your pattern model looks like, and suddenly you get a billing alert saying that something's going crazy, it's because your usage pattern has changed based upon a new script that went in, or a new feature. It's better to find out that the vacuum attached to your corporate credit card has been turned on high before the end of the month. But yes, scale your environments up and down as necessary. Almost done. Cloud is interesting because everything has a cost, and it can be measured. So if you're running the automation costs $45 a day, is that worth the time cost? Can you put is that worth the confidence you have? Are you willing to spend more money to have more confidence? Or are you willing to spend more money to have that confidence faster? So understand what a individual run of your scripts are, and then you can ask interesting questions around that specific dollar value. Again, cloud. Amazon doesn't want you to run data centers, so stop spending money on data centers, except when you have to. There's all sorts of interesting reasons why you might need to have a data center for your automation environment. Maybe you have robots like Tapster that running, and so you need to have a bunch of them sitting in a rack while they interact with dashboard, a navigation console screens or something to that effect. Most of the cloud providers have device farms, but maybe you have something special that you need on your devices. So you have a data center that has a device farm, but that still needs to be managed just like everything else. Okay, this should be the easiest question to answer in the world for a cloud environment, which is how much does our automation infrastructure cost? I remember squirming around that question when it was 5 racks in a data center, because we had no clue what it cost. But everything in your environment, there's various ways you can structure your environment. You can structure it as an entirely independent environment. So 100% of the cost is automation. You can tag the resources. So then you just look at the cost for the things that are associated with that tag. But you need to have a way in your automation environment to say, how much does this cost, per month? And then again, you can make questions, ask questions. Are we comfortable with that amount? Are we comfortable with double that amount? What would that do? Can we, get, our runs twice as fast by going parallel? Does that double our spend, or does it only add 40% of our spend? Because some of the stuff just costs on a monthly basis anyways, regardless of the load pattern. So that should be the easiest question in the world to do, to answer. But it also means that you're going to have to go deep dive into your bills, and they are not necessarily fun, but it's a useful skill to do anyways. And this dovetails off of what I just said. Your time is always going to be the most expensive part of any automation. And I suppose I should hedge that by saying it's not always the most expensive part of automation. If you pick the most heavy instance inside Amazon to run your automation against, yeah, it's going to be ridiculously expensive. But always, this is the classic build versus buy question. How much is your time worth, and is it worth paying somebody else to have to do something, or to do something so you don't have to worry about it? I am I don't work for Amazon, but I will never build an automation environment that's not in a cloud platform of some kind, because there's so much stuff that I don't have to worry about when running it there. And I will happily pay for this. In the Selenium space, the example there is Sauce Labs. Do I want to run a server that can maintain 150 different permutations of browsers? No. Here, take my money. Because my time is more, it's better for me personally to create new and interesting scripts against those things than try and set up and maintain them. All right, look at that. Lots of talking, but really, the end question is, the seed you in your mind is, are you well architected? Kind of, a fun way to wrap it up. Odds are you're not. Heck, I'm not even as well, and I wrote this deck. I run afoul of a bunch of these things, but this is aspirational. These are things that hopefully everybody got 1 or 2 things that they can be looking at this afternoon or later this week. Be like, oh, here's this tweak I should do. I should add multi-factor auth to my login credentials. I should enable logging in my automation environment. Can I get access to my Amazon bill and figure out how much my environment cost this month? And you can start picking away at these things. They don't have to be done in any particular order. You can just, take one a week for the next however many weeks that is, and look at it. There's any number of strategies and approaches that you can do, but I think that the well-architected framework is a really interesting way to think about your environments, and regardless of which cloud provider you're in, and is going to only improve the foundation that your automation runs again. So that, with 2.5 minutes left to the top of the hour,
Yeah.
is
Got a little bit of time left. So thanks, Adam. So if anybody has any questions, I know we have a couple of minutes left. We can go a little bit longer as long as the attendees are willing to stay for a little bit. But if you have questions, go ahead and get those in. There are questions already in. So you actually, Adam, said that so having your production data in your test environments is a liability. But what about if you download and sanitize that data? Or, for example, if you don't collect credit cards, is that still a risk?
Yeah, I don't there are all sorts of papers that you can find, especially from like DEF CON and such, that sanitizing your, if somebody gets your quote unquote sanitized database, they will, if they have enough interest in doing it, desanitize it. Especially if you have lots of aggregate data, because then there'll be the patterns that they can say, like, this person's this, here's these 7 records across the table that are correlated to this person. And if you get enough behavioral data in there, you can narrow it down a fair degree, especially if you can bring in external data sets into it. So just, I would strongly suggest never, ever, 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 ever pull your production database down into your environment. The secret to test automation or the test environment data is that it just needs to be data. It doesn't have to be readable. It just, everything has rules. And I've talked about this, I can probably dig stuff up on it. I've talked about this before. A name just needs to adhere to the rules of the system for a name. It does not need to be an actual name that some human on the planet has already. It just needs to adhere to the rules. So just generate. It's like, oh, well, we needed 1 million records. Generate 1 million records. That takes an hour to write a script to do that. Just randomize string data with the various rules that are around. Do you want double-barreled names? Okay, it's string data plus a hyphen. Are you allowing, Billy Bob with a space? Okay, it's, spaces are allowed. Are you allowing periods for, doctor or something? Okay, fine, that's allowed. Just understand what the underlying data is and just populate it as necessary. Then there's no risk if your database is compromised, because it's just junk data.
And to add on to that, there are actually a lot of libraries out there that will, like Faker, that will actually help you create a lot of that data too, that conform to some similar formats, but you don't have to do all the creation yourself. So the next question was, so you talked about hardware tokens and authentication, specifically security. You also mentioned hardware tokens. So is that something like each individual person that has access to AWS would have an individual hardware token, or just one for the company?
So it depends on your level of paranoia. So my level of paranoia is such that everybody who has access to the console of our cloud providers has what is like a software token, which is like Google Authenticator, sitting on their cell phones. And so if they get a new phone, then we have to reset the tokens, but that's easy peasy. But the root account of all of our cloud providers has an actual hardware token that needs to be purchased and synchronized, and that sits somewhere else. Because the very first thing you should do when you create an account at in a cloud provider is stop using that initial account and create yourself a lesser user. It's the same rule as creating a new Unix box. You never log in as root, you log in as some other user, that if you need to escalate your permissions, you do just that. You just escalate for that moment. So, but Google just announced a couple months ago, maybe, that they have all their employees now use YubiKeys, which are hardware tokens, and they've had no compromises and such. And then magically they started selling YubiKeys. here's this marketing greatness, and now we can also sell you what we're marketing. But that's just a bit of a conspiracy. But yes, like it depends on your level of paranoia. But at minimum, a software token to log in, SMS validation is not enough for controlling your infrastructure.
Great. I have a YubiKey. I think they're fantastic. I've started using mine for a lot more things as well. So the last question that we have is, you mentioned code comments and creating documentation. So the question is, I've worked in places where code comments are more of a code smell. And so I guess adding comments and generating documentation seems to sort of violate that code smell. Do you have thoughts around that? Is that like a specific thing depending on the company?
That's a cultural thing, right? So it's the, this is part of Uncle Bob's clean code stuff. You don't need comments because you're writing 3-line functions that are very obvious in what they do. But what if you are, how do I bring up my environment? What are the security groups that are being brought up in an environment for reason X? There's no reason why that can't just be a web page that's published somewhere. Here are the rules. Here are the print out a little grid. So that's a larger cultural question, and it's a personal. How do you feel about code comments? Like I don't mind code comments. Code comments have saved my butt tons of time. Code comments have also lied horrifically to me because it was a monster function, and it's like, this block does this, but somebody had changed the function for a bug and didn't see the comments, so didn't update it. So that's a cultural thing. It's up to you. I think the merits outweigh the downsides. When I was consulting, I had automation frameworks and the runners to drive your browser, and all of its documentation was auto-generated from the files in the framework. So I would check something in, and it would regenerate the documentation online. So your mileage may vary. I've had decent mileage with it.
Great. So I think that's all the questions that we have. So in which case I will just say thank you, Adam. Thanks for the presentation, and thank you everyone for attending. Have a great rest of your day.